Hello. So this recorded lesson is to complete the lesson we finished on our previous hours. Since time is short, I'd rather give you some part of the lesson like this, and then if you have any questions, you can give me in the live lesson later on when we have scheduled. For this reason, I'm going to share the screen as always, and I'm going to show you something regarding the graphing equations. Okay, so so far we have seen everything regarding equations, inequalities, absolute value, system of equation, a system of inequalities. Now we need to understand how to graph them. Of course, from this point of view, we know already everything about this amazing equation. This is an equation that provides us some information. This is key also for graphing. We already talked about the methods to recognize an equation, whatever the information are given, coordinate and slope and everything else. This formula is also important when we talk about the XY plane. That's why I left it here, and also the midpoint. Remember that each quadrant has a name. But now, the important part is about graphing. I just want to let you know something. On the SAT or ACT, you don't need to graph. Graphing is not part of the exam. However, you need to recognize the graphs or be able to point it out on any drawing that is given to you, okay, on the XY plane. That's why it's important that we realize how to graph. Now, let's start from the very basic, linear equation. How do we graph linear equation? First of all, whenever we have an XY plane, there are four possible cases of line that we have. An increased line, a decreased line, an horizontal line, or due to a constant slope, or a vertical line with an undefined slope. Here there are the three main cases. Now, to graph a linear equation, there are two possible cases. One is create a table and plotting its point, and one is using the slope and the y-intercept, as I was saying before. Now, let's see those cases. So, as I was saying, let's start seeing the drawing, how we draw a line on our XY plane. So this is the classic XY plane, right? This is my x-axis, this is my y-axis. Let's say that we have a simple equation like this one. This is already given us on the slope-intercept form. Let's see how to graph in the two methods we were mentioning before. The first method is by using the slope. We know that our slope is equal to 2, and the y-intercept, meaning b. B is our y-intercept, which is -3. And we start from here. -3, it's a point of our line, right? So our line will pass through this point. From this point now, we will use our slope to figure out where this line is gonna go. Why? Since the slope is positive, that means that we're gonna move one step to the right on the positive side of the x-axis. Since my slope is equal to 2, that means that I'm going to go 2 steps ahead. So now that I have this displacement, I can draw my line, because my line, as I told you, is going to pass from here, and then it's going to go and pass through the line made by the slope. Another method, which maybe it's simpler, just a little bit longer, is creating a table. How do we create a table? Well, having the equation, we can choose some values for x and y, right? Now, in general, from 2 points, only one line can pass through. For this reason, we just need 2 points on the table. Usually, for my personal perspective, the 2 points that I choose are the x and y intercept. Now, what's our what's our y-intercept? Of course, it's going to be -3. -3 is equal y when x is equal to 0. And we can see by just placing 0 on 2x. What when we put y to be equal to 0? When y is equal to 0, then my x will be equal to 3/2 or 1.5. So my 2 point in this case will be the y-intercept and the x-intercept, which you see is the same area where it's passing through. You can choose other point. It doesn't have to be in the 2-intercept. You can choose the point 1 for x. What happens when x is equal to 1? Y will be equal to -1, because 2 multiplied by 1 is 2, 2 minus 3, -1. And I mean, you can see it here. When x is equal to 1, your y will be equal to -1, and the point is right here. Okay, pretty straightforward. Let's talk about the system of equations. On the system of equation, we need to do the same process. Same, nothing changes. Now, here we have a system, 2 equations, right? That we will going to graph on this xy plane. I'm gonna underline this equation in blue, and since the equation is not on the slope-intercept format, I'm gonna put it like that. Actually, y equal 3x minus 4 because of all the passage and blah 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 blah. So now I'm gonna graph this line with the slope and the intercept that I know, right? So y, I'm sorry, the y-intercept is -4, right? Now what I have to do, since my slope is +3, I need to move 1 step on the positive direction. And then since it's 3, I need to go +3, I need to go 3 steps up. So now I have this point, I have this point, I can draw my line like this about this equation underlined in blue. Let's do the table for this other equation. 7x plus 2y = 18. Let's choose, as always, as the 2 points. I'm gonna choose when x is equal to 0, y will be equal to 9. That's pretty straightforward. When y is equal to 0, then x will be 18/7. What's 18/7? I don't know. So I'm gonna check it out. 18 divided by 7, 2.6, something like that. So right here. So we have first y9. Okay. So first my point y-intercept, it's higher than that one. I'm gonna put as that one. And I'm gonna do it in red, and the other point is here. And now from these 2 points, only one line can pass through, which is the line of this equation. And we graph the 2 lines of the system of equation. Let's go to an absolute value. How do we graph absolute value? To graph the absolute value, we need to consider the main rule of absolute value with the algebraic expression, which is the fact that when we take out the absolute value, what I will get are two results, y equal to x and y equal to negative x. Because of this final result, what I will get is a mirrored line, because absolute value of x equal to y will result to something like this. That's it. Then if we have a problem like this one, the graph of y equal absolute value of x minus 6 is the standard x comma y coordinate plane. Which of the following transformation when applied to the graph of x equal absolute value of x result in the graph of y x? That's pretty simple. The main situation is always equal to this one. When we have an absolute value on an equation, when we graph it, we have a mirror, like in this case. Now, the mirror case here, since the equation is that simple, will be just swift by 6 position to the right here. That's all. So my answer will be F. If it was positive, it would have been in the other side. Okay. And now we need to go over inequality. Let's take a break. When we talk about inequalities, and when we talk about graphing inequalities, the graphing it's slightly more complicated than an equation, but the process, at least at the beginning, is the same. So let's take a look at it. We already talked about inequality, all the characteristics. We talked about the fact that the properties, many of the properties of inequality are equal to the property of an equation. And the same, we talked about the system of inequality and absolute value of inequality. Now, let's talk about graphing inequality. When we graph an inequality, the first steps are the same as graphing any linear equation. So we need to draw the line. But then there are two main steps that are different, which is understanding what type of line we're gonna draw, because we can draw a dashed line looking like this one. If we have only a value, if we have an inequality that is either less or greater, or a solid line when is less n equal and greater n equal. This line will divide my graph in two parts. One of the two parts will be shaded. Now, why it will be shaded? The reason is because we're graphing on inequalities. And as you might remember, when we were talking about it, inequality represent a set of value. So the graphing, the shaded area we see here will represent all the set of values that inequality have. So let's see how we graph it, okay? First of all, we need to draw the line. So we take this equation right here, and the first thing we're gonna do is just deal with it as an equation so that we can find the points to graph it. In this case, I'm gonna use a table. As always, when x is equal to 0, my y is gonna be equal to 3. When y is gonna be equal to 0, my x is gonna be equal to negative 1.5. So now that I have those, I can just plot these 2 points. One is here, one is there, and only one line will pass through it, which is the line represented by that inequality. In this case, that equation. Okay. And that's the first step. It's the same one as for any equation. But now we need what we need to see is the inequality part. The first thing we need to check is the type of line. As we were saying before, if your inequality is with a less or greater sign, your line will be dashed. If your inequality is with a greater or equal, less or equal sign, you will have a continuous line. In our case, since our inequality sign is just a sign of greater, this one will be dashed. The reason why it will be dashed on the specific, I'll tell you in a minute. But now we need to talk about the second difference, which is the fact that one of the area of this XY plane will be shaded. You need to color one of these parts, either this part or this part. As you see, the line is splitting the XY plane in two parts. One part will represent all the possible solutions for that graph. How do we show that? Is on the following case. The classic case used by many books is choosing one point that is in one of the side. In this case, I'm going to choose the point of origin, the point 0, 0, and plug this value on your inequality. So in this case, it will be 0 minus 0 greater than 3. If the statement here is true, then the area that will be shaded will be the area where the point is included. But since in this case, the statement is that 0 is greater than 3, and the statement is just false, then not only this point is not included in one of the solutions of the line, but none of this area will be. The area that will have all the solution of the inequality will be this one. If, for example, we take point 0,4 and we plug it in on the inequality, 4 is greater than 3, that's a true statement. Now, we wanted to see before why the line is dashed. The line is dashed because the point laying on the line are not included on the solution. If, for example, we choose another point, point 3, 0, okay, the y-intercept, in that case, what we will get is 3 greater than 3. This is false, and it will be false on any point we choose from the line, okay? There is another method to figure out which area will be proved to be true, and that is using the method using the slope-intercept form. I'm going to show you in 1 second. Let's take again this inequality. Now, instead of looking from the point and blah, blah, we're going to take the inequality and put it in the format of the slope-intercept form. With, of course, one difference, which is this one. We are not going to have an equal sign, we're going to have an inequality sign. So if we take the inequality, we will put it in this format. We will get the y is greater than 2x plus 3. There is nothing else we need to do. Now we just need to look if y is either greater or less. If it is greater, like in our case, then your graph will be true by going up. If it was less, then your graph will be true by going down. That's it. Nothing else to do. I want to show it to you from the example from a book. Here we have an equation, which is this one right here, right? I'm sorry, this one right here. To graph the line, we need to use the corresponding equation, which is this one, which they do. But then, beside the fact that the line here will be continuous, because here we have an inequality sign that is less and equal, then they use the point to see which area to shade. They use the origin point again, and they see that the statement is true. That's why they shaded this area. What if we use the slope-intercept form. So again, the equation is this one, and I need to get to that format. What I will do, first of all, actually I have it already here, so I'm just gonna say y is less or equal to -1/2x plus 2. Whatever you see here, I don't care. What I care is the fact that y is less. Since it's less, I'm gonna go to prove it by going down. And that's it. That's it. So to graph an inequality or to recognize an inequality, those are the key information we need to remember. Okay. I want to go on and do the last step, the last type of graph that we need to recognize. And this one I think is the most important one. This question is from a preparation test. The question is saying if the system of inequality of 2 minus y less than 2x and negative x less than equal than 4 minus y is graphed in the xy plane above, which quadrants contains no solution to the system of inequalities. So what do we have to do? The first step, as always, is to graph these two inequalities. So I'm gonna make two tables here. First one for the red inequality, which will be if y is equal to 0, if y is equal to 0, x will be equal to 1. If x will be equal to 0, y will be equal to 2. The blue one will be if x is equal to 0, y will be equal to 4. If y is equal to 0, my x will be equal to -4. So now that I have the 2 points, let me graph the two equations. I start with the blue one, -4 and 4. From here, only one line pass. Okay, boom. Now I'm going with the red one. The point 1, 0 is this one. The point 0, 2 is this one. So from that, only one line pass. That is this one. Now we need to check if the lines are dashed or not. Let's start with the red one. The red one is telling me that this is just less. So the red will be dashed. We dash it. The points on the line are not included. The line of the inequality of the blue line will have a line that is continuous because here the sign is less and equal. So we leave it like that. Now we need to shade the areas. Which area are included on that inequality? Let's start with the red one. For the red one, I'm going to choose the point. I'm going to choose point 0, 0. And now I will have that from point 0, 0. I will have 2 less than 0, right? For this reason, this statement is false. And I'm going to shade it the opposite area. This one right here. Let's do it for the blue. And for the blue one, I'm going to use the slope-intercept form. So what I'm going to do, here I have -x less and greater than 4 minus y. I'm going to move the y in the other side, the x in the other side. I have y less or equal than x plus 4. Since y is less or equal, that means that the area that I will shade it is the area below the line, this one right here. Now we need to add a step. We need to add a step on all this passage. Why? Because this is a system of inequality. For the system of inequality, there is going to be a specific area that will prove the system. What's the specific area? The specific area is the area where both inequality are proved at the same time. In this case, is this one, is the area where the inequality are shaded one on top of each other. So this area right here that I have control, I have underlined in yellow, and I'm gonna color also in yellow, is the area that will prove always right the inequality. So that's how we graph a system of inequalities, and that's how we need to recognize it. Now let's try to answer this question, because the question was asking, which quadrant contains no solution to the system? Here we're talking about system, so it's only the yellow area that we're talking about. And what are the name of the quadrant? The quadrant are quadrant 1, 2, 3, and 4. Now, clearly, quadrant 1 and 4 are included. And also quadrant 2 is included because of this little piece right here. So this one is also correct. The quadrant that doesn't contain any solution of the system is quadrant 3. So quadrant 3 will be our answer. I hope all this was clear to you. If you have any question, please ask. I hope this video helped you out to figure out this part. We can go over some other example like this one on the next class. If you have any question, don't forget to ask me, and I'll see you in the next class. Bye.